Hello, Mr. Right? Okay, so linked list. Linked list is a data structure. So given this linked list, which has sorted elements, so 1, 2, 2, 2, 3, it's sorted, okay? And we want to remove the duplicates. So for example, look, this one, this sorted linked list, 1, 2, 2, 2, 3, and we want to remove duplicates. Then the result is 1, 2, 3, okay? The difference between the linked list and the array is that with the linked list, we can travel only from the head. Yeah, basically, it's a one direction. It's a directed a cyclic while, right? But it has only one direction. So each node has pointed, is pointed to the next element. Okay, so for example, if you want to visit the last element in a linked list, which is 3, so there is no way to directly jump to the last element. We have to follow the path from the head. Okay, 1, 2, 2, 2, 3. Okay, so the last element, which doesn't point to anything, actually it points to a null. Okay, null, but it doesn't point to anything. Okay, but with the array, on the other hand, is that we can visit any elements. We can have this random access to any element as we want. Okay, so nowadays we don't usually use the linked list that much because we can always replace it with an array. Okay. Okay, so given this problem, we are given a sorted list. We want to remove the duplicates from it, but be aware that the linked list is sorted. So this is already a sorted linked list, and we want to return this.
Yes, put it in.
Put it in.
Notebook, set, whatever.
That's a good idea. Yes, we can use the hashtag notebook, okay, to remember the
Dictionary.
Yeah, we can use the hashtag to remember the nodes we have seen. Okay, but this is more a general case. But given this array is already sorted, but if the array is unsorted and we want to remove the duplicate, and then we can use the hashtag. So we traverse the linked list, and if it's not appeared before, we keep it and we put it in the hashtag, right? If it appears in the notebook before, then we just simply abandon it. We simply just discard it. Yeah, we keep moving until we reach the end. Okay, so if this is sorted, simple, right? If it's sorted, so we just have to check the next element, am I right? Look, this is the key thing today. Okay, so look, what's the next element? It's 2, right? It's not equal to the current, then we move on. Look, 2, what's the next? It's 2, it's the same as the current one. So this is the duplicate, right? So, okay, so this is the duplicate. So what do? We are here. Now we are here. This is our current. So we found out the next element is the same as the current element. So what do we do to remove this regarding this pointer? So this is the next.
Delete.
Yeah, we delete it. So we just have to erase this to point it to next, right? And then we can remove this, am I right? Okay, and then the same. Okay, then we get rid of this. Okay, now this and this is the same. So what do? We redirect the link to point it to its next. Okay, and then this way we can remove it because this is the sorted. So we can always compare the current and the next one, right? Am I right? And as I probably mentioned before, almost every linked list problem we can convert it to an array, and it's easier. Am I right? Because array is a one-dimensional array, right? We can convert it to 1, 2, 2, 2, 3. Okay, so this is the array, and then if we convert the linked list to array, then the advantage we get is that we can use the array index to retrieve any element, and we can modify it as much as we can, right? So this gives more flexibility. One way is we convert the linked list to array, and then we do this remove duplication thing right here, and then we convert it back to the linked list. So basically we create another linked list based on this array. Okay, this is one general approach that we can use to solve almost every linked list problem. But for this problem, because we are given a sorted list, so we can always check if the next element, next node linked list.
What's this?
Cooling chip for CPU. Next element is the same as the current. If it's the same, then we just remove the next one by pointing the next pointer of the current node to the next pointer pointed by the next one. Okay, so let's write the code. Does it make sense, everyone? Yes?
Yeah.
Okay, let's write the code. Define remove duplicate given a head. If not head, we have to check if it's given a node or nothing. If we given nothing, then we return nothing, right? Because if we given nothing, nothing is a valid linked list. Return or return none, okay? Current equals head. Because we don't want to modify the head, right? We don't want to modify the head. So head, this is given the head. We don't want to modify the head. We return this head, right? We always return the first element because the first element can't be removed. So instead of modifying the head, we use a current. We set a current here. Current, okay? Current. So now this is the magic. This is the loop, okay? While current with the current node is not empty and the current dot next. So if we have a next element, right? If this current element is not none, we haven't reached the end, and the next element we still have one more node in the next. Then we compare if this node equals to the node, right? By the value. So if current dot value equal current dot next dot value, right? If current dot value equals current dot next dot value. Okay, so now it's equal. Then we have to point this current dot next, right? Current dot next equals to current dot next dot next, right? Right? Current dot next is this one. We want to point it to current dot next dot next. So it's this one. We want to point this to here, right? Okay. If it's not equal, then what do we do? If it's not equal, we just simply advance the current pointer to this one, right? If this one equals not 2, it's not equal to 2, so we just move the current to here and then we continue. So else current equals current dot next, and then we simply return head. Okay, so here this is the thing. We just pointed to this. Then what happened to this node? What happened to this node? We can delete it, right? If we don't delete it, we just leave it alone. But a better way is that we delete it. This is the node, right? So we say node equals current dot next. This is the node we want to delete. Current dot node. This is the node, and then after we redirect pointer to this, then we need to delete this. Then we use the keyword delete node. Okay, delete node. Make sense? The time complexity, simple. Time complexity. Okay. What n is
The number of
nodes in
the list.
a linked list. Simple, right? We can guess. The space complexity O1. Yeah, because good, because we just use a constant space here. Does it make sense now?
Yeah.
Is it simple?
No.
Okay, what's the noise?
There's an aeroplane.
Helicopter.
There's an aeroplane.
Okay. Okay, so what have you learned today?
Bye.
What have you learned? What have you learned today? Come on. Quickly, 2 or 3 sentences, and that's it.
Linked list.
Sentence, not
Remove
word.
duplicates from a sorted linked list.
Yeah.
The linked list.
Okay, we're given a
Bye.
sorted list with duplicates, and we want to remove it. What's the solution? How do we?
We remember them in a set.
No, we're not using.
We redirect
Hash.
arrows.
Okay, so let's say.
We hashtag thingy. We store them in our memory.
Okay, so how can we?
We just remove 3
Yeah, can you
So
yeah?
this thing, this thing,
Okay.
and then you redirect.
Redirect which one?
And then you get this, and then you redirect this.
Can you show
It
the
has to
redirect?
be. It has to. The next one has to be greater or the same. Otherwise, if it's lower or the same, then you delete it.
Well, actually, okay. So let me show you one more time. Okay, this is current. Okay, it's not equal to the next one, so I move it here. Okay, 2 is not equal. Okay,
This,
3.
this thing.
Okay, 3 and 3. This is the equal one. So I redirect this and then get rid of this. Okay, and then what happened?
Same.
Same, right? So I redirect this to the next, which is nothing. Okay. Yeah, make sense? That's it for today. Bye bye.
Ah!
Bye bye.